Hi, in this video we're going to talk about factoring special cases. We're going to do the following factoring. We're going to do difference of squares, perfect squares, factor difference of cubes, and sum of cubes. So let's start with the difference of squares. You may remember this from Algebra 1. If you have x squared minus y squared, that equals x plus y times x minus y. And the reason is if I were to multiply this out, and you should always be able to multiply out your factored form and get back to the original question, I'd get x squared minus xy, then plus xy, and then minus y squared. And those middle terms will always cancel out if it's the difference of squares because you have the plus minus. So let's do a couple examples. First thing, when you see two terms, you want to see is it a difference of squares or later on difference of cubes. Here, 2 is not a perfect square, you might be thinking, but you always want to remember to do your first form of factoring, which is a GCF. So here I can factor out a 2. And now if you look in the parentheses, n squared is a perfect square and 25 is a perfect square. You just want to remember to always carry along that greatest common factor when you factor it. So then I get an n plus 5 and an n minus 5. All right, now if you feel like, yeah, I remember this from Algebra 1, I think I got it, try these two, pause the video and try them and then press play again. If not, keep watching and I will explain them as I do them out. So we have 9g squared minus 16. 9 is a perfect square, g squared is a perfect square, and 16 is a perfect square. So I can factor this right away. However, let me add a caveat to that. Even if they're perfect squares, you do want to check if there's a GCF, because sometimes there is. But 9 and 16, there's no greatest common factor there. So here then, square root of 9 is 3. Square root of 16 is 4. 1's a plus, 1's a minus, and you're done. C looks a little trickier, but it's still 4h squared is a perfect square, and w plus 5 all squared is a perfect square. So you do the same thing, just do what you know, and square root of 4h squared is 2h, and square root of w plus 5 squared is w plus 5. Notice I'm putting it in parentheses, and that is especially important in the one with the minus in it, because I want to distribute that negative to the w and the 5. And then the other one, the plus, you can distribute it, but it doesn't change anything, so that just stays w plus 5. All right. So next is x squared plus 81. So if you see this, you should immediately write prime, because this is a plus, not a minus. They are perfect squares, but you can't factor it because there's a plus. A lot of times students want to factor it to x plus 9 times x plus 9. But remember, you should be able to multiply out and get back to your original question. So if I multiplied this out, I get x squared plus 9x plus 9x plus 81. This middle term doesn't cancel out anymore because we don't have opposite signs. So you don't get back to the original question. So you just write prime because it's not factorable and you move on. Just like prime numbers, you can't factor them, same thing. All right. Let's jump to perfect square trinomials. So there is a formula for this, and if you recognize them, it's helpful. But just know when we go further into factoring, if you don't recognize this pattern, you can always use some of the other factoring techniques we're going to learn to factor perfect square trinomials. So the pattern is this last sign is always positive, and so the first term has to be a perfect square, and the last term has to be a perfect square. And then if you take the square root of those and multiplied them together and doubled them, that would be your middle term. And then this sign just goes with whether it was a difference or whether it was a sum. I know that's a little confusing, so let's do an example and it probably will be clearer. All right, so first thing to check if it's perfect square trinomial is that a perfect square and that a perfect square? It is. So if I wrote this as 3g squared and this is 7 squared, this middle term should be 2 times the square roots multiplied together. So this comes out to 21 times 2 or 42g. So it does in fact equal that. Therefore, this is a perfect square. So it's going to be 3g and 7. And because this is a minus, oops, that means there is a minus here. And you are done. All right, so let's try this one as well. So this would be 5x squared, and this would be 8y squared. And then just to check, so this would be 2 times 5x times 8y. That would be 80xy. So this is not a perfect square trinomial, so we can't use this pattern to solve it. So for now, we're just going to move on from the question. Later on, with other techniques, we'll see if this is actually factorable or not. All right, a little bit harder one now. So we have this squared, and I'm going to change the 81 to 9 squared so we can look at the 9. So the middle term for this to be a perfect square trinomial has to be 2 times the n minus 4 times the 9, and 18 times the n minus 4. So that is indeed a perfect square trinomial because that's what our middle term is. So now I can put this in parentheses, and our first is n minus 4. And then because this sign, the first sign is a plus, we're going to have a plus here, and it's the 9 from the square root of the last term. And I can combine my terms, and this is n plus 5 squared is my answer. All right, now to another special case. We have sum and difference of cubes. So it's just like difference of squares, where you have two terms, but this time it's a perfect cubes instead of perfect squares. And also, unlike difference of squares, you can have a sum of cubes, whereas you can't have a sum of the squares. So I would write down these formulas. On the next page, I'm going to show you a little mnemonic to remember how to do this, because you might be thinking, how am I ever going to remember this? Right. So let me go. If you need to copy this down, pause it, and I unpause, and I will go to the next slide. Here is how you remember factoring perfect cubes. So the first parentheses is going to have the cube root of both of them. So in this case, a minus b. And it's going to be the same sign as the binomial. So if it's a minus, if it's a difference, that's a minus. If it's a sum, that's a plus. Then you're going to do squared of the a term, and it's going to be opposite sign of the original problem. And then the last sign is always positive. So that spells out SOAP. So same sign, opposite sign, always positive. And then remembering what goes between the signs isn't as challenging as remembering the signs usually. So it's just the cube root is in the first parentheses, then it's squared, squared, and those multiplied together. We'll do a few of these. All right. I'm going to have the formula up here, but I'll just use SOAP to remember this. So this is a cubed, and 125 is 5 cubed. So how I'm going to factor this is I'm going to do A and then same for SOAP. So it's going to be the same sign, so it's minus 5. Then it's the square of the first one. And then it's opposite, so same opposite. So that's going to be a plus. And then you do the two numbers multiplied together, so it's 5a. And then always positive. And it's the last term squared, so 25. And again, on a test or quiz, if you want to check your answer, you can always multiply this out, and you should get the a cubed minus 125 when you're done. Okay, so here's one. I would try this myself. So pause it here and then press play once you've attempted it. So this is 2g all cubed minus h cubed. So again, we're going to use SOAP. We do have the formula here, but I like SOAP. So we're 2g minus h. So that's the same. Then we are going to do 4g squared because we squared the 2g. And then opposite sign, so it's going to be a plus. The two terms multiplied together, so it's 2gh, and then always positive, and it's h squared. Oops. All right. Now we're going to try a sum example. Okay, so this time 8 is 2 cubed, so we're going to do same sign, n plus 2, then n squared, opposite sign, so we do a minus this time because this is a plus. The two numbers multiply together, and then always positive, so that's a plus 4 because it's 2 squared. Oops, put the squared in there. There we go. All right. So now, next example, you can give it a shot yourself. So this is 4 cubed, oops, 4m cubed minus 3n cubed. All right, so if we do SOAP again, so it's the same sign, so 4m minus 3n. Then we square the first one, so it's 16m squared. Opposite sign, so it was a minus, so this is a plus. And we do the two terms multiplied together, so we get 12mn. And then we do always positive, the last term squared, so 9n squared. Okay. So here is a summary of just how you factor each one in case you wanted to write down a little cheat sheet to have with your homework. You will need to know how to do this without it when it comes to test or quiz time, but this is good to have just while you're working if you forget them.